Welcome to Pre-Pocal Activity PG2. Our topic today is resonance structures. So we will have to understand our learning objective is to understand what a resonance structure is, and you need to be able to draw all resonance structures for a given compound. And then you need to be able to rank the major contributors. So we have three learning objectives for resonance structures. Okay, so what is a resonance structure? Resonance structures are a single structure that is a true representation of the organic molecule. So because we write in two-dimensional, we need to sometimes draw, an example, three structures that give a true representation of one compound. So there exists only one compound, but we might need to draw multiple structures. An example, acetic acid. Acetic acid is the active ingredient in vinegar. Now, if we move these electrons here, so we got pi electrons here, these are non-bonding electrons, and these are non-bonding electrons. The electrons that I put in red are your either pi electrons or non-bonding pair electrons. These are always located in a non-hybridized p orbital. So to represent these, this acetic acid structure is not a true representation of acetic acid, but rather we use this special double-headed arrow here, okay, to say that they're equal, they're the same, and we can move these electrons. And so we can move the electrons up on the oxygen, because this oxygen is an sp2, this carbon is an sp2, and this oxygen is an sp2. These electrons, the pi electrons or the non-bonding pair electrons, can move in these unhybridized p orbitals. I think of them as like an electrical wire. And so we have these here. This pi bond has now moved to a non-bonding pair. And if you do your formal charges, you'll see that oxygen gets a negative and carbon gets a positive. So this is a neutral molecule that we started with. And then this is a neutral because minus plus equals 0. And then we can also move these other electrons here. And so we will move, I like to go from this molecule here, so some people would do this. I'm going to do another one here, double-headed arrow, to say that they're equal. And then we draw a third one. I'm putting all my sigma bonds in there. And I'm going to start with this molecule here. And what if these electrons moved here? So, and then we have to do our charges. This is a negative, and now the oxygen gets a plus. So on these sp2 carbons and oxygens, those electrons can flow to each other. Now this is also neutral. So what three things have to remain the same when you're drawing resonance structures? Well, all of the atoms, hydrogen, carbon, carbon, oxygen, oxygen, hydrogen, they have to stay in the same place. Notice that none of these atoms are moving. So that is one of the requirements. So these sigma bonds all remain the same. The other requirement is that if you start with a neutral molecule, then your charges must equal the same. If you start with a negative molecule, overall negative, then every structure needs to have an overall negative. So you have to have conservation of charge. And pretty much, yeah. And also, if you count the number of electrons that are either a pi electron or a non-bonding pair, they should remain the same. Here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the next thing we're going to do, so after you figure out how to draw all the resonance structures for a given compound, the next goal is to rank the major contributors. And so you need to memorize the 5 major resonance contribution factors. Okay? So, and they're in this order. Number 1 being the most important, and number 5 the least. So the number 1 is for every atom to have a complete octet. That's number 1. Number 2, to have as many bonds as possible. Number 3, no charge on an individual atom. Individual atom. Number 4, if you do have a charge, you want to have the negative charge on the most electronegative atom. And if you have to have a positive charge, you have it on the most electropositive atom, or the least electronegative atom. And the least important is also if charge exists. You need to have small charge separation. Okay, so let's do another example, and we'll apply these 5 major resonance contribution factors, and we'll rank them. So let's go back to acetic acid. So we'll go ahead and draw acetic acid. And I'll put the lone pairs in red. And then we want to draw a resonance structure. We see that these electrons here, the pi electrons, can go to a non-bonding to the oxygen. We draw all our sigma bonds in again. Sigma bonds are single bonds. And then we draw our lone pairs. That makes that a negative, makes that carbon a positive. Okay, and then we draw another one where these electrons here go towards the carbon, and this is acetic acid, which is the active ingredient in vinegar. We draw our lone pairs here on the oxygen, which makes it a negative, and this lone pair has now become that one. Then oxygen, and oxygen has 3 bonds, 1 lone pair, so that makes it a positive. All right. Now, the most important is a complete octet. So oxygen, hydrogen, carbons, these all have a complete octet. These do not, okay? 1, 2, 3, 4, because the carbon does not. So this would be your number 1 major resonance contributor, okay? As many bonds as possible. 1, 2, 3, 4, 5, 6, 7, 8. This has 8 bonds. You count the lines. 1, 2, 3, 4, 5, 6, 7. 7 bonds. 1, 2, 3, 4, 5, 6, 7, 8 bonds. Okay? And so this would be the next one. So this is number 1. This would be number 2. No charge on individual atoms. So that one's good. This is no charge on individual atoms. These both have charges. If you have to have a charge, you want the negative on the most electronegative. You see, you got that here, oxygen. And you have your positive on the most positive. Least important, if the charge exists, have small charge separation. This is actually less charge separation than this one here, but because number 2, as many bonds as possible, 8 bonds wins over 7 bonds. So this is number 1, this is number 2, and this would be number 3. So your pre-POGL activity that's due tomorrow is the following. You need to draw all 3 resonance structures for the following molecule. So I will draw the first one. This is the first resonance structure, and then you will draw 2 more. Make sure that your arrows for electron flow and for resonance structures is drawn correct. And this is here. I'm also going to put these in red so you can see you have 3 non-bonding pairs on oxygen with your negative charge. You have that pi electron, you have that pi electron, and then oxygen here has 2 lone pairs. You need to be able to draw another structure and another structure. Make sure you have your rules where the atoms are kept the same number of pi non-bonding pair total electrons, and overall conservation of charge, which is here overall is a negative, so these compounds need to have overall negative charges as well. And then I want you to write out all 5 of these major contribution factors, and then I want you to rank your structures from 1 being the major contributor, 2 and 3.